All right, let's just dive right into it. If you're a developer or, shoot, even just curious about tech, you've definitely heard the battle cries, SQL versus NoSQL. And look, this isn't just about picking some piece of tech. It's a massive architectural choice that pretty much defines how your entire application is going to work. So the big question is there one perfect database for every single job? One that can handle anything you could possibly throw at it. For a really long time, it actually seemed like the answer was yes. But as we're about to find out, the world got way more complicated, and that whole idea of a single ruler for the data kingdom, well, it got completely shattered. To really get the revolution, you first have to understand the empire it overthrew. And for decades, decades, the world of data was ruled by one super powerful model, the relational database. Just look at this timeline. It shows you just how long this era lasted. It all started with a paper back in 1970, and by the mid-80s, SQL was the undisputed standard. We're talking about a 25 to 30-year run. That's basically an eternity in the tech world. If you were building something that needed to store data, you were using a relational database. It wasn't just an option. For a long, long time, it was pretty much the only option. So why did it reign for so long? Well, the secret sauce is this powerful little acronym, ACID. This was the absolute promise of SQL. Atomicity meant your operations were all or nothing, no half-done jobs. Consistency made sure your data always played by the rules you set. Isolation meant different operations wouldn't step on each other's toes. And durability? That was the big one. It guaranteed that once you saved your data, it stayed saved. Period. That was the magic recipe for rock-solid reliability. And this, right here, illustrates the trade-off perfectly. Relational databases, they get a perfect 5-star rating for consistency, that ACID guarantee we were just talking about. But take a look at scalability. Oof, just 2 stars. This is the crack in the armor, the one big weakness that was eventually going to cause some major problems. So what happened? What was the huge event that finally challenged SQL's 30-year reign? I can sum it up for you in one word: the internet. The absolutely massive scale and, frankly, the chaos of web data pushed that old model to its absolute breaking point. All of a sudden, you had companies like Google and Amazon that weren't dealing with thousands of transactions a day. They were dealing with billions. They needed to handle these gigantic datasets with unbelievably fast write speeds. They were getting frustrated with the rigid structures of relational databases and really wanted something more flexible. Oh, and they wanted to do it all with open source software, not crazy expensive commercial licenses. The old king just wasn't built for this wild new world. And this is where the rebellion really starts to get going. It began with some incredible work happening inside Google, which published these groundbreaking papers on its new file system and a database they called Bigtable. And these weren't just theories, these were battle-tested systems that were already handling web-scale problems. By 2009, this whole movement finally had a name, and it came from a simple Twitter hashtag for a meetup: NoSQL. Now, to really understand NoSQL, you have to get this fundamental dilemma. How do you handle more and more traffic? Well, you can scale up by just buying one gigantic, super powerful server, or you can scale out by adding more and more regular machines and just distributing the work across a whole cluster of them. For the longest time, SQL databases were really designed to scale up on one single powerful machine. But see, scaling up has some really serious problems. For one, you eventually just can't build a bigger machine. There are hard physical limits. You've also created a single point of failure. If that one mega server goes down, your entire application is just offline. And yeah, the cost gets absolutely astronomical. This just was not a sustainable path for the new giants of the internet. So this forced a complete rethinking of the whole problem. Engineers realized they had to make a choice, a huge trade-off. They started asking, what if we sacrificed some of that perfect 5-star consistency that SQL gives us in exchange for, well, near infinite scalability? And it's so important to get this point. The movement wasn't about killing SQL or saying it was bad. In fact, the name was pretty quickly recoined to mean not only SQL. The whole goal was just to create an alternative, a new tool for a new class of problems where the old relational model was just a really poor fit. This really gets to the core of why NoSQL databases even exist. They were born and bred to do one thing exceptionally well: scale out. Their entire architecture is built around this idea of spreading work across a huge cluster of machines. This is what gives them the massive scale and high availability that modern, global applications absolutely have to have. It's their entire reason for being.
But scale wasn't the only problem on the table. There was another, more subtle kind of friction that had been bugging developers for years. And it was this awkward relationship between their code and their database.
Is called the object relational impedance mismatch. Okay, it sounds super complex, but the idea is actually really simple. See, developers think in objects, like a user object that has a name, an email, and a list of posts. But a SQL database thinks in flat tables, rows, and columns. It's like trying to fit a square peg in a round hole, and you need this kind of clunky translation layer to make them talk to each other.
So think about a user profile, like on LinkedIn or something. In a relational database, that one single profile is basically shredded into a bunch of little pieces and stored across a ton of different tables. A users table, a positions table, an education table, you get the idea. To see the full picture of just one user, you have to do these complex and often really slow join operations to stitch it all back together again.
Now, NoSQL document databases like MongoDB solve this in a completely different way. Instead of shredding the data, they store that entire user profile as a single self-contained document. Just look at it. Everything for that user, their profile, their jobs, their education, it's all in one place. We call this better locality, and it perfectly mirrors how developers think about objects in their code. It just gets rid of that whole impedance mismatch problem. Okay, so we've covered the history, we've covered the key differences. Now for the really important part. How do you actually choose? Which one of these tools is the right one for your job? This decision matrix is basically your cheat sheet. You want to use SQL when your data is highly structured and the relationships between data points are absolutely critical. Think about financial systems, e-commerce orders, anything where that ACID guarantee is totally non-negotiable. And you want to use NoSQL when you need massive scale and high availability, or when your data is a lot less structured. Think social media feeds, IoT sensor data, or logs from a video game. It's all about matching the right tool to the right problem. So, the great database war, it's kind of over, and the outcome wasn't a single winner. Instead, we now live in an era of what's called polyglot persistence. Fancy name, but it just means that modern applications often use multiple types of databases. Each one is chosen specifically for the job it does best. You might use a SQL database for your billing system and a NoSQL database for user session data, all inside the same application. And really, at the end of the day, the whole database debate comes down to this single question. It's not about which technology is better. It's about really, truly understanding the trade-offs: consistency versus scale, structure versus flexibility, and then choosing the architecture that best solves the specific problem that you have right in front of you.